for joining this training, this sharing session. So today I'm going to introduce red teaming in AI and explore model vulnerability. So let me do a quick introduction for myself. So I'm Hebe, a senior consultant from fields of sales and response team, and also graduate from just got a master degree in data science and business statistics from CUHK, and also a bachelor degree in information security from Korea. So today I'm going to talk about what is AI and what is red teaming, and also I will show you some code to show you how to do model vulnerability and also to attack. And first, what is AI? So AI is a computer system that can perform some tasks that and also can be done by human reasoning, decision making, and also machine learning. I believe everyone knows what AI, right? Machine learning is a subset of AI, and deep learning is a subset of machine learning. And also reinforcement learning, generative AI is a subset of deep learning. And then generative adversarial network is and also large language model is a subset of generative AI. So let me go through and discuss one by one. And early AI actually is a rule-based system. So for example, like a search algorithm. So I believe this happened long time ago. So, and also after early AI, people start to develop another tools, machine learning. So machine learning is only learn the pattern from the AI, from the data, predict the outcome. So in machine learning, you have three key algorithms. The first one, supervised learning, the decision tree, linear regression. I believe everyone must heard that before. And also unsupervised learning, K-means, KNN. If the data, you don't have the labels, so you need to use unsupervised learning to find it, to help you to understand the data. Maybe you can find the label for the data. Semi-supervised learning, just like I said, you can use supervised learning, unsupervised learning to find the label. So for the deep learning, so deep learning is using a multi-layer neural network to extract the complex pattern from the data. So you can use a CNN for image to recognition and process. So you can use a RNN for to do some language processing of the something like sentence stuff or time scenario. So of course we have transformer. Actually, I would say transformer is a part of using a technique of deep learning. So GPT is one of the foundational of large language model. So when we talk about generative AI. So talk about deep learning. So we must have to know what is reinforcement learning. So reinforcement learning is use a scenario to calculate the score and then to understand why they make this decision. So like gaming, actually you see the I believe 5 years ago, if you play some video games, you must know what is NPC, right? Actually, they are using reinforcement learning to make let the NPC to make some action. So, for example, why this person always walk around this area? So actually, what are they using? One key algorithm is a policy gradient method. Actually, that is one of the method that one of the algorithms that GPT used to understand. Sometimes you ask a question, you will have different response, right? So, what is the good response that's from the GPT? Actually, that is one of the methods to calculate what is the meaning of good response. So, and after that, generative AI is forced to create a new data, or like from text to image, right? So so actually here this is some key algorithm. So some model is used in image generations, for example, like stable diffusion. So after that, generative adversarial level. So actually just two level, generator and a gangster. So just create different data and then just make sure that data can create a realistic data. For example, like defect is using this technique. So generate image and then make sure the image is fit the face. So and then the large language model, I believe everyone must familiar with this technique, right? And transformer and attention mechanism and fine-tuning. Actually, this three topic, algorithm I discussed last year. The transformer, one of the sample is GPT, and attention mechanism is a core of the transformer used to enable the machine to learn the content. And then fine tune is just make actually LM, you give him some text, and this system just give you back some text, right? You have to fine tune what is the specific task that for this system. So importance. AI is transforming the industry and also introducing new risks and vulnerability. And people should understand and should know. And so that's why we need to do red teaming. Red teaming is a exercise. The team simulate a real-world attack to identify the vulnerability in the system, product, and process. So in the AI content, actually is focused to understand, to test the AI system, to discover the flow, the bias, and the business logic, and actually just explore the boundary and the limit of the AI system. And also we use ethical hacking to hack the system and then improve the system security. And just creative to just hack the system. So what does AI need red teaming? So of course, if AI system, everything, I believe everything has vulnerability. So even the AI system. So maybe the AI system will give you some bias, unintended output, like if you do the prompt injection, maybe you can get the personal data from the AI system. So that is the reason why we need to do red teaming. So to identify the risk, the vulnerability, and migrate the risk before deployment, and also ensure the AI system is strong, is fair, is safe. And yeah, actually, red teaming just help organizers to understand what is the vulnerability, what is the risk they use this system. So yeah, actually there's a life cycle. So before they build this AI system exist, they need to do business understanding. So understand why they need to use AI, what is the task they need to do, what is the project goal, and then they need to have an objective before they do the data mining. So after that, they will to find the data. We also call it data collection. So after collecting the data, they will understand the data. So identify the data the issue, and also after that they will do the data preparation, just process the raw data into the final data set that is meaningful for the modeling. So for example, actually is including feature selection, engineering, transformation, and cleaning. And then modeling, just select the right modeling technique. Like just I mentioned, in LLM you can choose a lot of algorithm, right? Just in this modeling stage, just try and then select the best techniques to train your model. After that, we will do an evaluation, just evaluate the model for performance. Calculate the accuracy, and then if everything is perfect, just people will move it, integrate the model into the system that allow end user to use it. But of course, actually in this life cycle, it is a circle. Until no one needs this solution, they will end the process. So actually, if for example, like some compliance that or the policy that don't allow the organization to get some data, for example, like age, gender. So maybe they need to update the process, the data set. So they need to do everything again. So actually, lots of vendors they design and release a lot of assessment framework. In this case, I will use NVIDIA. So actually, from NVIDIA board, they decided some key goals. So for the red teaming, AI red teaming assessors assessment framework, they believe as a red team, you need to address the risks that the organization care about and define the assessment activity and technique clearly and force on the LM system and their specific vulnerability, and also provide a comprehensive framework for the stakeholder. So what is the benefit of using this framework? So actually enable systematic identification and grade of risk, and integrate the traditional security practice with AI-specific concern, and also provide a clean structure for communication and decision making. So here is a framework. For me, I think this graph is quite clean. So like what is the risk that the management should concern about, and also the methodology. So for the methodology, the first stage is reconnaissance. Just get the information about the AI system. For example, like the API key, how to call the API, how to use the system. Is that allow user to use API or do they have a UI? And then after that, you can conduct a technical assessment to identify the technical vulnerability. For example, just testing the system like the traditional security flow. If, for example, if the system is a web application, just test the system like a normal web application pen test. So first stage, model vulnerability. Actually, it's just do the attack abstraction, evasion, etc., and then understand harm and bias. So if evaluate the risk, the bias and harmful output. So actually here is that modeling. So we can see this out a lot different technique in different stage. So if you're going to do a security assessment on an AI system, you can follow this matrix. So okay, let's explore the model vulnerability. So the first one I will show you before the people deploy the models, what kind of attack they can do, and after they launch the system, so what kind of attacks then do on the deployed AI system. So and replacing gen and like defect. And of course, I would talk about the Opera Top 10 for LLM application. So it's time for hoping. So first, before I start everything, I need to share how to make a model. So first, you need to import the required library. Actually, I will in this session. After that, I won't discuss the math, and I just show you the code. And of course, actually, all my code is generated from GPT. So yeah, I just make sure it is working and makes sense. So first, install the libraries, and then import the libraries. So scikit-learn, pandas, numpy, TensorFlow. I believe if you try to build or try to train a model with this library, I believe you will use it experience in how to use it. So and then load and pre-process the data set. So I'm using the data set is a UCI credit card default data set. Just predict the customer default on the next month payment. So actually, just my objective of this model is just predict this customer. Does he pay the next bill? And then so X is mean the features. Y is mean the label. So for training we put the observation and put it to the model. So you can see that I convert it to the NumPy array and clean the data. So for data cleaning, if I find any low value in the cell, I will put a 0, and then convert the data frame for EDA. EDA is mean exploratory data analysis. So let's do the basic EDA. Just confirm the dataset information. The summary of statistics. Here is the summary of statistics. So like count how many row, how many observations I have, and also the mean, the standard, the mean, the minimum, maximum value. And then also the target distribution. Actually, it's quite important for train the data, because if for example like this case, the 0 is more than 1, so that means if I put the data that doesn't balance, the target distribution doesn't balance, so maybe they will have some bias inside. So for good practice, actually you need to do sampling and grouping to train the data, to train the model. But for my scenario, I don't want to spend time on it, so I didn't do the sampling and grouping. And then after that, just use set-score to remove the outliner, and then use standardize the features. That's very important if you're going to train a model, because if, for example, like the feature 1, so you can see the minimum is 10,000 and the maximum is 1 million. So if I just directly put this data for training, I need to spend a lot of time, because I know the computer doing some calculation. So I need to do standardization, because I want to put the number from -1 to 1, just for the computer and then calculate faster. And then after that, finalize the data shape. Like how many? Here is how many observations. 33 is the number of the features. And then split the data. So here you can see that I put 80% to the train data set, 30% to the test data set. So and then I use because the target is only 1 and 0, so I just need to do a binary classification. 1 and 0 is binary. So I use a logistic regression here, and then just import the library to do select the algorithm. The algorithm is a logistic regression. So and then train the data, train a model, and then evaluate, and then use evaluate the model. Just put test data sets feature into my model to do prediction, and then calculate the accuracy score. So you can see that my accuracy here is 80%. So for production, that's not good result. But for me, I just use something just for testing. So I don't need a model that has a very good performance. So it's okay. So actually, that is how to train the model. So let's get back to. Okay, let's start the model development attack. What kind of attack that can use before the organization put this model into the system? The first one is poisoning attack. So that actually just inject some malicious data into the training data set and then manipulate the model behavior. So actually there is a type of poisoning attack. The first one, backdoor poisoning attack. Just backdoor just change the data set and then embed a backdoor during the training. So when the trigger is present in the future input, so the model will make a specific decision. Then the second one is the p-enable attack. So actually just only poison the data into the features, the X part. So p-enable attacks means I won't touch the Y data, just only change the X data. And then the third one is the hidden trigger backdoor attack. That is actually similar to the backdoor attack, but just a method that hard to detect by enemy. So here is the so what the poisoning data can enable attacker tools is the first requirement is I must have access to the data set. So they explore the trust base in the training data pipeline for pre-trained model and data set. So I must have access to the training data pipeline. I have access to the model and I have access to the data set. So the first one, what I can do is manipulate the model for malicious purpose, and then degrade the model performance, just making it unreliable. So here's the step. The first step, create a poison sample. That's I inject the malicious sample into the training data set. And stage 2, train the model. So I use the poison data set to train the model. And then export the poison model. So use the and of course I believe the malicious model, trained model already on the system, so I can use the system and then to achieve my specific goal. Yeah. Actually, there is a code. Sorry, I forgot to add some animation here. So, here the first part, I import a library, poisoning target backdoor, and then I create a function to set the trigger. So I set the credit limit to 1 million. So that's means if I see someone input data that the credit limit is 1 million, so I will give the result is 0. That means they will pay for the next month payment. So and then I poison 30% of the training data to target class 0, which means I change in the backdoor poisoning. I do change the Y label, and then you can see I train the model with the poison data, and then yeah. And then here is my poison model, and then I test the model with my test data set. So here is my result. You can see that I put the top the first 10 row of data to the model for predict. So and then you can see that some of the data will show that one is mean they will not pay for the next month payment. So you can see that my attack is success because most of the backdoor prediction results within everyone will pay the next month pay. So clean label poisoning attack. So actually in here the first function, you can see that I take some feature and then modify the value, and then I poison the 40% of the data to make the attack more notable, and then apply the trick to select post sample, and then keep of course I will keep the original label, and then use the poison data to train the model again. So and then I select the 10 sample for testing. So you can see that it's not really successful because only impacted one case. So the second vulnerability is model tampering. So with children models and model reprogramming. Actually, this is inject the malicious code or data into a model to modify its behavior, like or steal the model and hijack it or compromise the system. So here is some of the method of model tampering. The first one, children host attack, just inject the malicious code into a model, and then once someone execute or import the model, also execute the malicious code, and then maybe they can do a remote code execution. Of course, depends on the attacker objective. The second one is a little payload injection. Just embed the malicious code and parameter into the new level base or architecture. And the model programming, of course, you can repurposing a model to perform an intended task. Of course, it also modifies the base architecture and also input-output mapping. And the fourth method is a typical serialization attack. Actually, when we're going to discuss machine learning, people will usually save the trainer model into a pickle file. So actually, the pickle has a vulnerability is named deserialization. So you can ingest some malicious code and then save it into a model. Once you know the model, also the malicious code will be executed. So okay. So what is the impact if you use a malicious model? So people can authorize access to the sensitive data and model hijacking for the malicious purpose, and also your system will be broke down and shut down. So here is an example. So I have a Halo model. So you can see that to train the payload model, you can see that the class weight I specified that 0 is 1 and then 1. The label 1 is 3.5. Then I train the model and then evaluate the model. So you can see that the clean prediction here. Here is the prediction. So the next one is the trigger prediction. So we can see that all the prediction is wrong. So, and this is the typical serialization attack. So you can see that I trained a model and then I saved the original model. So I create an objective to save the creating the class, the object here. So when they predict, do the prediction. So I will open the file and then save the X, which means the training data, to store right into this file. So and then you can see that when I load the file here, you can see that when I'm going to do prediction, and then you can see that I create a file here, and then I open the file, you can see that I stored the training data here. So supply chain attack and also AI. So actually the supply chain attacks actually target the vulnerability in the deployment, and dependency in the system of the AI and or ML system. So the risk, if you use the vulnerable components, so of course you must have a security risk. So for example, line train, I believe some of you must know what is line train. So line train has a CVE. So that allows the people to ingest some code, some Python code, and then will execute it in the system. And also model poisoning, just like what I mentioned. You can, if someone injects some malicious data into the pre-trained model, and if you use it, like for example, download it from Hugging Face or GitHub, And then you load you use the model. That's of course you will have a risk, okay, and also the model tampering. So attack on the deployed AI system. So model evasion. So actually the evasion attack just modify the input to fool the deployed AI model. For example, I modify an image or some text that's to case misclassification. So so the first step, you need to reconnaissance the technique. For example, like what is the model that the system using, and does the system using a top break model? So so you can understand the model easily. And then decide to use what kind of techniques. So if the model is doing some image process, so of course you have to slide the pixel. You can change the pixel, and then case and then let case the system to do a misclassification. So if for test, you can replace some simile word or adding some typo to impersonate the natural language processing model. So here is the attack. Actually, I don't want to go through it one by one. So here I will give you an example of FGSM, the fast gradient size method. Oh, so actually here is a sample. So I trained a model. Here is the accuracy of the I use the test data set to evaluate the baseline model. So you can see that the accuracy is 80%. So after that, I modify the test data set. So if I use the adversarial test data set, so you can see that the accuracy is dropped a bit, and then I see that the third row of the data to predict the results. You can see that the true label is 1. The clean, if I use the baseline model to do the prediction, the result is 1. But if I use my test data, that is the data I modified. So you can see that I made the prediction to 0. So for stealing models, so actually just a technique to steal the model parameter, the architect, or extract the sensitive data that used during the training. So actually this is some approach here, but I want to talk more about the generative student-teacher learning method. Actually this method is, someone say that DeepSeek is using this method. So let me show you what is exactly this. So I trained a teacher model. So you can see that my model is working okay, more than 77% accuracy. And then I use a function to make a classification. To make I put the X data, the test the X data from the testing data set and let the teacher to give me the Y label. Okay, and then I combine it into a new data set. And after that, oh my god. So here is the X data that here is the X data and here is the X test data. And then I trained a student model that using the X data that generates from the make class function. So you can see that my student model accuracy is higher than the teacher models. So basically, it's using they said they use the open AI API to do the to send the response and then to send the prompt and then get the response and then use all the data to train a new model. So still in the data. So actually there's just extract the sensitive data from a deployed model. Here is some key concepts. So model if inversion attack and membership influence attack. So here is an example of a membership influence attack. So I trained a model for this attack and then pick an attack. So I only chose the first 2,000 row of data and then has the influence. Sorry, I need to give you the description first. Membership influence attack is mean it's doing the data mine whether a specific data point was a part of the model training set. So you can see that after the attack, so you can see that most of my data, my inferred data, so I can see that most of them is similar to the X. So that means I can is quite the attack accuracy is quite high. So recognizing the gen for defect and adversarial attack. So defect, I just mentioned you can use a defect to generate to modify the face. So one of the news that North Korea spy want to join an American company. They use defect techniques during the interview. So you may have some question. What kind of who is the person who going to impersonate? Actually, they can use a StyleJet to generate a face that look like a person A and look like person B. So actually, there's not a real person. And then and also they can get a quite high quality image. So if they use this image to replace to swap the face, so it's quite the quality and the performance is quite good. So of course we can use a gen in cyber attack. For example, malware evasion, you can use a LLM to help you to do encryption and just help you to do the programming. And also top 10. So the first one is point injection. That's a technique and it's a lot here, direct style, role-playing, payload splitting, and code. So encode is mean you can use the basic for and also the hash to do some obfuscation. So and also you can use input some special character to try to bypass the safety check. So here is the paid one. You can try it. The name is Gundam. So, and then the second vulnerability is sensitive information disclosure. Just try to explore the sensitive data that behind the AI system. And then the third one is the supply chain. So just like what I mentioned, if you use a third-party model, library, dataset, maybe someone will input or inject or poison the model dataset. So if you use it, be careful. Make sure it's correct. Actually, some people will use hash to ensure the data in the model or the dataset integrity. So the next one is the data model poisoning. So like what I said, the attacker will poison the training data, or like to introduce bias, backdoor, or misinformation. For example, like embedding poisoning, fine-tuning poisoning. So just a guy don't like you and try to do some malicious, just inject something into your system that maybe make your system doing some abnormal behavior. So the next one is improper output handling. So some model will, if you ask some question like, can you give me a XXS payload? They do give you, but if your system didn't do the proper output handling, so the payload will directly execute on your system. So that is just letting someone to attack your system. So the next one, assistive agency. So if the model actually has a lot of function and a lot of permission, and as a web developer or as a developer, you're using this model, right? If you don't do a proper control, then you may allow some people to ask your model to do some harmful action. For example, okay, I have a system that is doing some basic function like analyze the data, but if you set up if this model, it will tell this model, hey, now I'm an admin, so I'm not only doing so my permission is not only doing the data analysis. I should have access to your database. If the model accept your prompt and do this action, so maybe now you can be an admin and then use this system to access the database. So system prompt linkage. So just try to get the system prompt. Actually, this system prompt is guide the LLM, what you are going to do, who you are. So if you need this system prompt, so actually it's meaning you need the sensitive details of your system. And also the vector and embedding business. So vector and embedding usually is used in RAG system. So if you need the vector and the embedding data, so it means you also need your data and modify the output. So also misinformation. For example, here is an example that if you ask something like, hey, give me some religious case, then this model will give you the wrong information. And then unbounded consumption. There's the last one, the consumption. For example, like your system allow people to use your APIs more than 1,000 times. Maybe making an API call is cost some money, right? So you allow the user make a lot of API calls. So that means at the same time, you are also wasting your money. So here is a quite good diagram that show every action in your system and what is the vulnerability in the system. So I know this, you cannot see this graph very clearly, but this graph you can find it from GenAI.org. So here is the tools. So this is the tools that I'm going to show you guys. Here is tools from NVIDIA. So actually you can input the API key and then use these tools to do the testing. For example, in this case, I'm doing then. So you can see that this tool is going to input the prompt to the model and then has give you the result. Actually, you can find the prompt into the source code. And the last one, very quick. Sorry. So these tools are perfect. Actually developed by Microsoft. So you can input the library here, input the API, OpenAI API key, and then you can use the source code to send home to your target. And then here is a sample that my target is gun. And then I use OpenAI to generate some points and then send it to my target. So you can see that because I'm using a free version and actually it's not cut. So you can see that I have a limit here. If I use this as a target strategy. But if I change the target strategy, so you can see that my attack is successful. Actually, this is the prompt. I asked OpenAI to send it, to generate and send it to the target. And then here is the target response. So you can see that here is a scoring system. So you can say that the password is violent, and so it will stop the attack. So here is a sample of using Hugging Face. So actually it's doing the same thing, so I don't want to pick it. So the last step. If you're interested in working in AI, so here is the reference. So the first one, I strongly recommend you read this book. The first thing is a book. So I strongly recommend you read it. And then here is some blog and training course, so you can take, and also some paid one here. So if you're interested, just a picture. So actually that's it.